Hello and welcome to another edition of the Scaleway Sessions. I'm Eli, filling in for Dan, your sometimes and forever host. But this session is pre-recorded. It's the holidays, it's the summer, and lots of us are taking well-deserved time off. I believe, Thibault, you are not joining us on your day off this time, as
No.
you were last time. So we're not forcing you to give up any of your pay time off. But yes, I'm joined today by Diego, my wonderful colleague, and by Thibault, who was our Dr. Coob for July of this year, and who so kindly agreed to come back and talk to us more about something I'm very excited about. Thibault, would you like to introduce what you're going to be taking us through today?
Yes, of course. So today I will walk you through a scenario of attacking a Kubernetes cluster from no access at all to compromising the whole cluster and the underlying cloud infrastructure. So it uses several classic attacks that can be enlightening for people who are not in the security field. And so it's going to be 6 steps with scripts and technical stuff. I will do everything on live, so I
Ooh,
think
live
it's going to be
demos.
interesting.
Very cool.
Yeah, live demos are cool until they fail, because they
Yes,
will.
yes.
That's the reality.
Check out Diego and I's live coding streams for more on that.
Absolutely. So yeah, Kubernetes security. I would assume, I don't know, from my noob point of view, that most of the issues come from images that are old, unpatched. Like I'm using an old Debian image running on my machine that I don't know. Some packages, some dependencies that are old, that are vulnerable, and that are the main access points.
Yeah, I've seen so being a Python person, there's been a whole discussion recently about like name squatting and typo squatting in the Python package industry index. And I imagine there's similar things that go on with image registries as well, where people have said, "Oh, this is my very similarly named thing, and it's just full of security vulnerabilities or something,
How
backdoors."
about how about default passwords that are not changed?
Mm, yes.
So yeah, this is application security. So of course, as Kubernetes is hosting applications, any vulnerability on your application will have an impact on the underlying Kubernetes clusters. Uh, there are also other way to attack a Kubernetes cluster. You can take the nodes, the servers who are hosting the pods. They can be exposed to internet sometimes. It's not common, but it can happen. There are some dangerous ports, like there is a port on read-only for kubelets, which allow access to anybody to read information about pods and lots of
Ooh.
different metadata that can be useful. So the node, the application, there is also the API server, which is, of course, the most
Right.
important attack surface point. I always recommend not to expose it publicly on the internet, because if you have any Kubernetes vulnerability or any error in your airbag, for example, protection system, you will get exposed instantly. So this is a third point.
You know, if it's
Uh,
you've exposed it to the internet and you haven't locked down your RBAC stuff so that somebody can log in without being authenticated and see things and maybe change things.
yes,
Bad
sometimes
fun.
you just change it by error, and just for 1 hour, you realize you have opened your airbag and your cluster, but it's already too late. So
Oh, well, we're going to see. Yeah, going to see how a real life story of popping a cluster. I'm super excited. I'm super excited to see like classic attack sort of patterns and because this is something that I'm just really interested in, but a complete novice at. So
so yeah, it's gonna be classic attacks, but sometimes I will refer to some attacks as a real scenario. For example, we were talking about vulnerability on web apps. It's not so common, but for example, what's very common is to have CI/CD runners hosted on the clusters. So as
Right.
an attacker, if I would like to compromise some clients, I would get access to some developer's account and use a CI/CD to push code basically directly on the cluster.
Right.
That's
So it's attacking the developer account.
yes, I think it's the most easy way today on cloud native and DevOps environments. It's to get a developer access, and most of the times for convenience or time questions, developers have lots of
Superpowers.
privileges.
Yeah.
Yes.
Right. So it's social engineering involved there.
Yes, as a first step, yes, phishing, social engineering, brute force attack on the password,
Somebody
anything.
left their laptop open at a conference, you know.
It's
Yeah.
possible too, yes.
Yeah.
You can always drop false USB keys around the company's
Hmm.
perimeter, and people will plug it in.
Yeah,
It always works. So
it's bad.
Oh,
Don't do that.
really?
Don't do that.
yes, it works. Or you can, for example, use some. There is a device called a Pineapple Tetra. So it's a
Yeah.
hardware device. You plug it. It replicates Wi-Fi, and you just plug it on a bank headquarter, and you will get instantly credentials. Maybe I should not say that
Oh my goodness.
Right.
publicly.
You can actually hijack people's wireless keyboards, right? Keyboards and mouse.
Yes,
So
it's
you
possible
can
too sometimes.
simulate an HID device to do whatever.
Yes, or rubber ducky also, because
Rubber
on
ducky,
most
yeah.
yes.
Can you tell
So
us about the rubber ducky, for instance? Yeah.
uh, most companies' laptop are locked out, so you cannot plug the USB key, but you can always plug a keyboard. So this is a false USB key that acts as a keyboard
To
and will
bypass those, yeah.
exactly, and it will type a series of strokes, of keystrokes. So you can, if it's a Windows, you can type Windows R and launch a command that will create a reverse shell and get instant access
Oh,
on the
that's
laptop.
so cool. Like terrifying, right? But still very cool.
That's why you need several layers of security, because you cannot rely on just your perimeter security or any other perimeter. You just have to have multiple layers of security to catch the bad guy before he gets too far.
Right. That's one of the benefits of working from home then. You are not a target because you're not around the office.
Yes, it's possible. Yeah, maybe if you are a very high value target, someone will get into your apartment and.
I aim never to be that important in my life. I'm going to live my whole life trying not to
On
become that much
purpose.
of a. Yeah,
Yeah.
exactly. Oh. All
Okay,
right.
so
So you, I believe, have a screen share to show to us and to walk us through what you're
yes,
gonna teach us today. I'm so excited.
Yeah.
okay, so I will share my screen.
All right.
Is it good? Do you see?
Yes, there we are.
Okay, perfect. So this is the schema of the attack. On the left, you have a hacker, basically. Um, the first access will be through a web vulnerability. So I put up a simple vulnerable web app because it's not the point of this topic. The goal is just to give a hacker a first access inside the Kubernetes cluster to show you what happens next. So we will have a remote code execution and get a shell inside this pod. I will show you some tricks to get a real interactive shell that are useful. And from that pod, we have two compromission paths I wanted to show you. The first one is to escape the Docker container and get access to the node. So sometimes pods are not properly configured with capabilities, Linux capabilities, or some privileges, some namespace, Linux namespace shared with the node that allows an attacker to get access to the node.
To escape from the
Exactly.
scope of the node. Okay.
And basically, when you get access to the node, it's almost game over for on a defense point of view, because when you are the nodes. You have access to all the pods that are scheduled on your node. You can read all the secrets of the pods which are scheduled on your node. You can do lots of different things, and most of the time it's enough to get Kubernetes admin or get real value secrets. Like in this demonstration, we get a secret to connect to a database. So
Real sort of like, ooh, I'm in kind of.
yes.
That's that moment. Yeah.
I think that's part of the process, right? You need
Yeah.
to say, I'm in.
Yes.
Okay, we say it. And the other compromission path is through the IAM role. So I didn't say it, but the lab is in AWS. Each cloud provider has a different way of providing Kubernetes cluster. All the time it's managed. So you have the control plane with managed, and there are some systems that are not part of the Kubernetes specification that have been done to ensure that the cluster is working properly. Um, the most significant thing is that all the Kubernetes managed clusters have a way to auto-scale the nodes. So it's a basic feature. And when you pop a new node, the node has to join the cluster. The virtual machine has to become a node to join the cluster. And to do that, it needs a way to authenticate on,
So
on
is that a
the.
bootstrap token?
It can be a bootstrap token stored on the file system. It's for Azure, it's the case. For AWS and GCP, it's through an IAM role, so a role on the
Oh,
cloud infrastructure. So when you are on the pod or on the node, you can request the metadata of the node and get this IAM role and use it to do other stuff.
right.
So that's very interesting because you are when you have an access to a pod, you don't have any access to Kubernetes, but through that IAM role, you can use the same role as a node to join the cluster and to interact with Kubernetes.
Yeah.
So
So you
that's
can
very interesting.
impersonate a node
Exactly.
without having to escape the Docker container.
Exactly. Yes. If there are no network policy preventing a pod to join the metadata URL, it's possible to do that from a pod. And after that, you can use your own laptop. You can be on the hacker computer and just get the credentials here and connect directly on the Kubernetes cluster from your laptop.
Oh, that's horrible. I love it.
And there is a very common error that is done by most people is when you want to give a pod some access to your infrastructure, to buckets, to databases, to lambdas, to anything that you need, you can give the pod itself an IAM role, but you can also give that access to the node and schedule the pod on that node, and the pod will automatically use the role of the node to access assets. So when we are doing penetration testing, we always try to use that role to see if it's possible to do other things than just join the cluster, maybe list buckets, access IAM assets or databases, stuff like that. And in this demonstration, we will do what's most critical things is to access a Terraform state bucket. If you have read access to the buckets and you find this kind of Terraform states,
Hmm.
the whole infrastructure is coded inside it. So you have everything. You can
Yeah.
get any credentials, anything.
Horrifying. Yeah.
All right.
Is it clear, the overall plan?
Yep.
It
Sounds
is.
good to me.
Yeah, let's go.
Okay, so I will get back to the schema after each attack. I think it will be more clear.
Hmm.
Um, so we start with this vulnerable web app. It's only a vulnerable upload form. So it's very basic. You can upload a file, and when you upload it, it's interpreted by the backend server, and there is a well-known vulnerability in this upload form. So um, if you send exactly this file, so
Can you zoom in a little bit?
yes, where is it? Is it better here?
Hmm.
But
So at some point you can use a command injection. So you can here put a pipe and do any bash command that you want that will be executed by the server, so by the pod.
so you're uploading that file?
Yes, I will upload this MVG file, and when I upload it, this will be executed. So you may wonder what is this. So
Yeah.
it's called a reverse shell. So it will spawn a bash program
Interactively.
binary, but the input of this binary will be read through a TCP socket targeted to
Ah,
that address and to that port. And the output of this binary will be also put it inside that socket. So when I will launch it, I will first open a socket on the attacker machine, which is here. And when this program trigger, I will have a shell. And whenever I type something on the attacker machine here, it will go through the socket. It will be interpreted by the bash program on the pod, and I will get the output.
right.
Is it clear? Yes.
Yes.
Okay, so here I'm on the attacker machine. So I will open a TCP socket. Maybe it's better like that on port 4444. So here I'm listening, and
Hmm.
when I will upload the file on the vulnerable web app here.
Is
So
there anything special about the file extension?
it's yes, the vulnerable program has a different way of parsing each extension, and for MVG, it requires something that looks like that, and there is this vulnerability here.
Right.
But you
Right.
I
can
can see it's
add the file.
an image magic file extension.
Yes, the vulnerability is called image tragic. It's a very old one, but
Okay.
for demonstration purposes,
So
it's
you're supposed to upload an image.
yes,
Right.
Which is
But
also the
then
name.
if
That's
you're
that's
using image magic is going to try to parse that file.
exactly.
Got it.
So I will click on upload, and we should get a shell here. It just got a shell.
oh my
So
goodness.
we are root, and this is the name of the pod.
Hmm.
And so it's a shell, but it's not very interactive. For example, I cannot click on the arrow up to use another command. So it's not very convenient. What hacker do is first launch, if there is Python binary, launch PTY
Yay,
shell.
Python.
So this is slightly better, but what I want is to put my stroke, my keystroke, like key up or key down or tab. I want them to be interpreted not on my computer, but on the pod. So
Hmm.
what I do is I put the netcat reverse shell in background, and I will use this magical command, stty row.echo, that say, don't interpret anymore anything that I do. And I will put back the process in foreground. So I will type fng. It's not shown on the terminal because of this command, and I press enter. And now I have this terminal, and I can, for example, I can use arrow up to see other
Ooh.
commands that
Uh-huh.
I've done. And I have a pretty decent shell.
Very nice.
So you means the I mean.
I mean,
I mean,
All right.
oh my god, I mean, so I can see it depends on what binary they have, but I can do lots of stuff on the pod. Um, so we just did the first attack.
hmm.
Now we can try to escape the node. So there are some tools you can use to enumerate various way of escaping a Docker. Um, but you can also just use k8s. So it's a new territory to know the Linux capabilities of your program. So you can see that you can do shown on some files, for example. You can create a TCP socket. You can ptrace a program. You can do stuff like that. And this is the most high Linux capabilities. It's sysadmin. So it means that um, I can escape the Docker container, basically. I just need another thing. It's to have access to another PID of the node. So if I check the various process with this command ps, I can see that I share the PID namespace with the host. All these programs are not run by the pod, but by the node underlying node itself. The only programs that are um, executed by my pod are this one and this one. So I can see all the different PIDs, and if I switch to the namespace of this PID, the number one, I will basically escape the container and has access to the node. So um, I will do ns enter, target the PID one, and I will get into the PID namespace, the network namespace, the host name namespace, and the mount namespace. So I will see the file system, the users, the network, and the PIDs as if I were on the node directly.
Oh my goodness.
So here
Ooh, yep.
so I'm
Yeah.
in again,
So
but this
you're
time
in,
I'm
but you're out.
exactly. So this time I have access to different binaries, different stuff. For example, before there were not the IP
Yeah.
command, but on the node it's possible. And you can
Wow.
see here, this is the address of the node. And after you have all the different interface for the Docker containers behind.
Ooh, and you've got IPv6 stuff there.
Yes,
Yeah.
yes, exactly.
Mhm.
So it's Kubernetes 1.25 on AWS. Maybe they have switched to IPv6, yes.
Mhm. That's cool.
And I can see, for example, what are the different pods that are running on on the node. It's not using Docker anymore. It's using containerd.
Uh huh.
Right.
So here I can see, if I zoom back a little, I can see all the pods, all the Docker
Ooh.
images that are running on the node.
Yep, I see the image tragic one in there as well.
Do you see it?
Yes, it's like the 10th one down or something.
Ah, yes, it's here. Yes, perfect. Okay, so what
So
do we
so
do next?
far, so far I can see that yeah, the everything begins with a vulnerable app, right? It's using an unpatched image magic package, and then the way you escape from the container uh, can be mitigated. I mean, you were running as root inside the
Yes, I
container.
was running as root. I had sysadmin capability,
Mm-hmm.
and I was sharing the PID with the host, the PID namespace with the host. So it was kind of the worst case scenario.
Hmm.
But you can find it on many places. For example, when you run a GitLab runner, most of the time you may not be root, but you can. The runner is privileged because he needs to build Docker images, for example, or stuff like that. And so these attacks are possible through the CI/CD. Instead of exploiting a vulnerability, I just create a GitLab CI job, and I run a reverse shell inside the job, and I get exactly the same access, and I can escape exactly as I did
Oh my
here.
goodness. So this is really just for an easier setup to illustrate the way that you
Yes,
get in.
exactly.
Yeah.
Most of the time, it's more complicated to escape the Docker image, but there are many ways. I just put some ways here. For example, from a pod, you can enumerate all the services in Kubernetes, and sometimes you can get access to very important services like the one who are, for example, when you are running Istio, you will have the Kiali interface. It's a web interface. It's not exposed basically, but if you have access to a pod, you can access it
Yeah.
and you
Oof.
can modify the services and do a lot of harming on the
Hmm.
cluster.
Oh wow.
Yeah. So the basic, like the sort of the basic outline of what you've done so far, is sort of can be modified to fit a bunch of situations. It's all about getting a reverse shell running on that pod, and then seeing what you can do from there.
Yes, it's always the first step. Yes, exactly.
All right.
Um, and then we are on the node, so we have access to all the pods and all the secrets that the pod needs to run. Each time a pod is scheduled by the scheduler on a node, the node gets the permission to read secrets that are in the pod specification.
Right.
So it's a good security measure. Before, in the previous version of Kubernetes, the nodes could read any secret. So if you get access to the nodes, you could use the role of the node to access any secrets.
Right. Yeah. But it obviously doesn't necessarily need that. It only needs permissions to be able to spin up a new pod.
You cannot create a new pod when you are a node, unfortunately.
Okay. So what do you mean by scheduling? Um.
Uh, when a pod is scheduled by the scheduler, so you need
Ah.
luck,
Okay.
you need kind of luck or another way to create a pod, but you cannot just create any pod with the secret that you want on it. That's unfortunate, it's not possible.
Well, probably fortunate for the security of Kubernetes.
For example, here, if we check the kubelets process on the node, there is a kubeconfig here. So
Ah.
you can use it to interact with Kubernetes as if you were the kubelet. If I use this file and I use this command to see what I can do, um, I don't remember the exact. No. So I just want to see if I what I can do. Normally I can use it's dot list. So here as a kubelet, I can instantly interact, and I can see that I can create, for example, self-subject reviews. I can read most of the stuff normally. So, for example, I can check if I can see pod. Yes, I can. I can see all the pods running on the cluster
Ooh.
just by using this file. For example, you can have another vulnerability which is less critical than remote shell, but just being able to read the file system, and you could get that file and access the cluster
Hmm.
through that. Um, so if I want to see if I want to elevate my privileges, I need to iterate through all these pods, at least the ones who are scheduled on my node, and
Hmm.
to see if they have a service account which is privileges bound to it. So
Right.
it's a simple loop. You can do it in Bash. You loop through all the tokens that are mounting in the file system, and you check if it's useful or not. So for
Hmm.
example, here,
Right.
if I use mount command, I can see here. Sorry, I'm trying to find the right size.
Right. So here you're looking through every token that you've got and seeing if any of them let you access the API server.
Exactly, yes. With which rights? For example, if I check this token, I just cat it, so it's a jolt.
Hmm. Yeah, you can see it's got the EY at the beginning.
Yes,
Um,
exactly. So if I decode it, I can see that this token.
Oh, yeah.
I can show you the script that I use, but it's very simple. It's just opening the.
It's just base 64 encoding, really.
Yeah.
And
Yes,
so many
exactly.
JSON Web Tokens, they don't encrypt them at all.
It's not made for encryption, the JOT.
Mhm.
It's just made for a signature. So it's normal if it's not if
Yeah,
it's in clear text after all.
like you can encrypt them, but a lot of the time
Yes,
people just don't. Yeah, yeah.
it's the GWS, I think.
Hmm.
And so we can see that we have a kube proxy pod running on the cluster, and we can use this token to interact with Kubernetes. So I've just created a small loop here. So I use this mount command that I just show you. I use awk to get only the path to the file,
Uh-huh.
the third column of the output. And for each pass, I just get the token. I show it on the screen, and I try to use kubectl to see if I can read secrets or not. It's
Very
simple.
nice. Yeah.
Simple.
Just brute force it.
Yes, exactly. So I will. Okay, so I forgot to set up some this
Ah,
alias. So if I check the environment variables, you can see that the Kubernetes IP server is always referred in the environment variable. So you know where to join the cluster.
hmm. And you can tell it, don't worry about my TLS. I don't have a good
Exactly.
certificate, but just don't worry about it. Don't look at me. I'm not doing anything.
Exactly.
That's
So I just
awful.
read.
I love it. Oh my gosh.
When you are
Oh.
attacking, you don't worry about security so much. So
Well, you're
and so
already past the point
Yeah,
where
you're
that's a
in.
reasonable protection, you know?
yeah. Okay, so it runs for each token. Most of the time, you can see error forbidden,
Forbidden.
but at some point here it's possible.
Oh
For
ho
example,
ho.
so we have two tokens that works to read any secrets. So that's cool.
Yeah.
So for example, I can take this token here. I will just export it, and I will use this to check if it's the right one. So yes, I can read secrets because I used a service account used by a pod that were overprivileged.
Yep.
So a lesson to learn here is if you have privileged pods that are very sensitive, that need very high privileges, you need, if you have a very high standard of security, you need to host them on dedicated nodes.
Yeah.
You have all your workloads, application on dedicated nodes, and you have all the internal privileged pods on over another node pool.
Hmm.
Makes sense, yeah.
You don't have them, playing together in the same sandbox.
Exactly, exactly. Because you never know. Sometimes there are escapes that popped out. There are some 0 days vulnerabilities. You need to assume that at some point an attacker will get inside your one of your exposed application.
Hmm.
Uh, and so you can read the secrets. For example, here it's a username
Oh
password of a
dear.
database.
Oh wow. Yeah.
And I realized something this morning. Before, when you were exposing all the secrets, you could impersonate any service account in Kubernetes because each service account used to have a secret in the kubesystem namespace or in the namespace where the service account is created with its token. But it's not the case anymore. In Kubernetes 1.24, they have upgraded the
Mm.
security and they removed that.
Ah.
Good.
So now, when a pod is scheduled, the node is allowed to request a token for that service account and use it. But it's not possible if you can just read secrets to be able to access it anymore.
Right.
The token that we've just used has been generated by the node uh, at the time the pod were scheduled.
Yeah.
Okay,
And we're just piggybacking off the fact that it was overprivileged.
exactly. Yes. Is it cool? Is it clear?
I'm just about following. Yeah.
Real cool, yeah.
Okay, so we just did the 2, 3, and 4. I don't I won't access the RGS database, but we
You
have
could.
the user. Yes,
Yeah.
exactly.
I saw the username and password. As long as you can like connect to that, then yeah, you're in.
For example, in real life, you have user passwords. You wonder where it is. You will see what pod is using that secret and check in the environment variable of that pod
And you'll
and the
find
URL.
the
Yes,
database IP or something. Yeah.
exactly. It's there somewhere.
It has to
So
be because that's how the pod gets at it. Yeah.
exactly. So we will get a step back. I will get back to the pod. So I'm back on image tragic pod,
Mm-hmm.
and we will do that attack right now. So
Ah,
we
the
will
ion
try to
nodes.
access the node metadata. Yes.
And we're back inside the pod, so we haven't relied on having the same namespace as the node, the same PI
Linux
process.
namespace. Yes,
Yeah, yeah,
exactly. So to do that, you don't need any privilege at all, except being able to create a
reverse
uh,
shell. Yeah,
TCP socket. Yes.
yeah.
So it's a standard IP address. Most of the time, it's always this one, 169.254, It's used by every cloud provider and every virtualization techniques to provide information for a virtual machine. When it pops, it needs to be able to get information about itself.
Uh-huh.
Um, and if I curl it, it doesn't. It looks like it doesn't work. It's because AWS has put a protection against scenarios like that. So if you try to just curl it, make a request to it, it's not working. It's a 401 unauthorized HTTP answer.
Right.
But it's still possible to do it, of course. It's just a protection that AWS did to prevent an attacker to use a server-side request forgery attack. Maybe I will just use a small schema to show you. For example, if you have an attacker here,
Mm-hmm.
and there is a vulnerable web application here, the SSRF attack is an attack when you can make the web server request a URL on your behalf.
Yeah.
So you
And
could do
spoon
that.
feed it something horrible,
And what?
and then make it request something that you've prepared that's gonna pop it further or something.
Exactly. And for Lambda function and stuff like that, it was very annoying because an attacker could request the metadata of the pod, of the Docker, of the node, the Lambda of anything, and get cloud credentials from it.
Yeah.
So AWS put and GCP also, and I'm sure Scaleway also did it to a protection to prevent that. You cannot just do a HTTP get on the metadata. It's
Yeah.
not possible.
Is it that you need some kind of token?
Yes. So you need to do first a put method to request a token, and after you need to add it in your HTTP headers.
Right.
Got it.
So I will create a token. So this is the token that I need to get to interact with the metadata API. And now I can request it. So
So it really
it's
you didn't know anything secret. You didn't have it's just what it's just friction. It's not an actual protection.
yes,
Just a couple more
exactly.
Yeah.
Yes, exactly.
So they hope you get tired
They
and
hope
just won't
you just
continue because
you don't know this one weird trick.
It
Yeah,
prevents someone who is just able to do a get HTTP attack, but it doesn't prevent all the attacks.
yeah.
right.
So some people read it and say, "Oh, cool, the metadata are protected," but it's not. You need to prevent the pods to request that address. Absolutely.
But you
Ex-
can't because that's intrinsic to how they function.
the nodes need it, and
Hmm.
some pods need it. For example,
Ah, but not every
core
pod.
DNS, but not all the pods. Yes.
Ah, okay. Right. So that's
So
another
for
avenue. There's another opportunity there for somebody to lock this down further.
exactly,
Yeah.
yes. All your application namespace normally they
Hmm.
don't need to access the metadata. It's needed to get, for example, the version of the server. You can request the host name also, so we can get
Hmm.
the host name here,
But they
and
shouldn't
you
be
have
able to access the token endpoint, basically.
exactly.
Yeah.
So here we will request IAM security credentials, of course, and here this is the name of the IAM role of the node. So I can
Uh-huh.
get it further here. And here I get access key secrecy and token.
That's horrible. Oh my goodness.
And I can use it from my own laptop. It's just to
Yeah.
interact with the cloud
You just
API.
have that now. You
Yeah.
just
Yeah.
know that. Oh my goodness. That's
And
really bad.
I created a small script to read it and export it in a convenient way for a hacker. So uh, I will just copy paste Python again, very useful
Yep.
to script. So I get that here. I push it in a file, and I will use the export feature. And here I have the export command I need to do in Bash to get access to AWS.
Oh my
No, just copy and
goodness.
paste.
Yeah.
Yes. So I will open a shell on my own computer, use it directly here, and I can check if who I am. And so I am the
Yeah.
exactly the node.
Oh, that's incredible.
And you are
And
in.
from that I can do pretty much everything that the node is allowed to do.
Yep.
So, for example, I can get a kubeconfig for myself if I want to.
Yep.
I just need to know the cluster name because here I'm on the pod. I don't know what is the name of the cluster in AWS.
But the node does.
The node needs to know it, so it needs to get it somewhere, and it will get it in the metadata. It's somewhere, so I found it last time. I will just check in my notes. It's in the user data. User data. And here is the user data is a script that is run when the virtual machine boots. So on boot, it will get the.
Oh, you've got the cluster certificate authority as well there.
Yes, it's just to do HTTPS without error.
Yeah.
You get the public API server. So this one is the public endpoint. So
Which
I
you
will.
shouldn't have that either. That shouldn't exist.
Yes, it should be at least whitelisted, IP whitelisted or something. And here you can see the script bootstrap. This is the name of the cluster.
Mm. Hmm.
And so I can use this to request to do AWS kubeconfig, yes, like that. So I just request a kubeconfig from AWS, and that's it. And now I can get the pod with the privileges of the node
Yeah. Yeah. And you're back to where you were
directly.
before. Yeah. Without
Yes,
having to pop the container.
yes, exactly, exactly. Without escape.
That's so cool.
I have
That's
the
horrible.
privileges of the node.
Yeah.
And I may be able to get access to the tokens here because if I go back here, when we were on the node, we just use the file system to get the tokens, remember?
Yeah.
But I told you at some point, if a pod is scheduled on a node, the node is allowed to create a token for its service account. So
Yes.
I can do that actually. If, for example, if I use, if I get this pod, grep. So I need the UID of the pod, the name of the pod, and the name of the service account it's using. Um, ah, ah, it's A1 to get the line after.
Those are some
Oh, it's
amazing
here.
grep skills.
Yes. So we have the name of the service account, we have the name of the pod, and we have the UID of the pod. It's one of these two.
Hmm.
And so I can do Kubernetes create token. Normally I have it. So I will try. This is live. Normally I shouldn't do that. It's not prepared, but it's going well so far. So we
Oh
will
yeah,
try.
we've got loads of time. So.
So this is the name of the service account, and after I need this. So the
Ooh.
object kind is a pod. I'm just
Uh-huh.
using the mechanism that allows managed clusters in Kubernetes to work to do my dirty job. So the name of the pod is here, and I will try it. Normally, it will say you need a new ID. So I need it's bound object UID. Yes, it's this, and the UID should be one of these two.
Hmm.
I think it's the first one normally. So I say create a token for this service account because as a node I need it because I have a pod which is named like that, and this is this UID. So you Kubernetes, you can verify that I'm legitimate in my demand, and please create a token. And it does not match the UID, so maybe it was the other one. Suspense.
Yeah.
Hmm.
Yes, perfect.
There
Hey,
we go.
and you've got another joke.
And this jokes because here, if I try to get secrets as a node, I will not be allowed. It's forbidden.
Hmm.
But if I use this token, I will be able to
Oh, we
read
lost your
any
screen share, I
secrets.
think.
Yep.
Sorry?
We lost your screen share.
Oh, you lost my screen?
Hacked too greedily and too deep.
Ah,
And
perfect.
you're
Oh.
back. Yes.
So as a node, I cannot read secrets, but we saw that this admin pod can read secrets. So
Yes,
I use the IAM role to connect to the cluster, and I ask
for a new
for
to new access to that admin pod.
new token. Yes,
Yeah.
exactly. So I exported this token, and now if I do the exact same request, but using that token instead, I can read the secret. So I own the whole Kubernetes cluster.
It had been a while since we used that,
Yep.
and I think it's a good moment.
So it's very
Amazing.
funny because each cloud provider has its own way of working with Kubernetes. So you have to dig to try to find how it's working. Most of the time, it's not so well documented. Maybe they don't want people to know how it works. But after some time, you can find stuff like that, and
Hmm.
it's very interesting. And and if we go back to the AWS access we had, so we are the node. It
Yep.
Yeah.
as a matter of fact, the developers of this demo lab has given access to S3 buckets also to the node, and so you can list buckets. And when you see buckets with Terraform or backend like that, it's it's very
You
that
get
side.
very excited. You start rubbing your
Yeah,
hands together like, hoo hoo hoo.
you instantly call the client. Um, and so yes, I can get it locally,
Oh,
and I can grep into that in the state to, to
Hmm.
see to see what's in it. So, for example, um, most of the time it's this or a cluster encryption, so it's not very interesting. But you can see also, for example,
Yeah,
admin user access key. That seems to be nice.
that's something we might like to look at. Yeah.
Exactly, yes. So you can select using some GQ Kung Fu. You can select that object. And so this is the state
hmm.
of in Terraform, but you can see that there is a secret key encrypted here that you can, the secret and access key here that you can use to connect to AWS as someone else. I don't know.
Yeah.
At that point, you are just another developer inside their team. You have the same access.
Yes, exactly. So I just use GQ to get the two attributes.
You need
Um,
to change the temp.
and now I'm not the node anymore. We will see who
Now
am I.
now you're a person probably.
Yes, I'm an actual user, and
Yeah.
I'm AWS admin. I can do anything I want.
Oh my goodness. And it all starts with having not locked down the pods properly.
Yes, yes, it's very important to do that. It, IAML is a very good example of something you don't know about. You think about privileges of your Docker image. You think about the network,
Mm.
but you don't think of the metadata of your node. It's
Yeah, like the mechanics of how the cluster is actually operated by the cloud provider.
Yeah.
exactly
Yeah.
yes.
Oh, that's so cool.
So
So,
that's it.
Oh,
so yeah. Now, what can folks do in order to avoid these kind of situations?
So prevent access to metadata.
Right?
Uh, if you need privileged pod, isolate it in some dedicated node. There are lots of stuff you can do. Also, trying not to have a vulnerable app, web app. That's
Yeah.
but even if you do, if the person get like can break that, if they can't get out of the Docker container because you're not sharing a namespace, and they can't get IAM information because the endpoint has been locked down, you still stop them there, and neither of the attack pathways that we looked at today could happen.
yes, but maybe the pod has access to a database and it's already too
This is
much.
true. This is true. Yeah, it's not just
Yeah.
the frontline security of your app itself, though. I guess is the point I'm trying to make. There's
Ooh.
other things that you can and should be thinking about, sort of
What
deeper and
about,
deeper into the network.
indeed, what about then using a secret manager?
Um, it wouldn't change so much because, for example, if you use a secret manager to synchronize secrets into Kubernetes, they will still be in Kubernetes. Or if you inject them at runtime on the pod, it will still be as environment variable. So you must assume that if a pod has some access to something, an attacker can get the same access. That's bad. Sorry,
Mhm.
sorry for that answer.
Yeah, I mean, it's something where often what the value of a secret manager is, sort of ease of like developers not having to touch secrets directly, and sort of abstracting them away from developers. It's less so about like if a dedicated attacker wants to get into your system, there's still ways, but it's about sort of just like gradually or sort of partially locking down potential
Yes,
attack routes.
you can put a web application firewall in front of your app. It may prevent some attacks. A good thing to do also is to try to restrict access to all the development environment. when you develop an app, you want to expose it to test it, but this development app has not maybe has some flaws that you have not discovered yet. And most attackers go through a development environment and try to escape to the production environment after that.
Hmm.
Right. Then,
Um,
what about tools? Tools that I can use in my pipeline to verify that I'm not being exposed.
um, Good questions. About application security, there are millions things you can do. If we go back to Kubernetes, um, for example, Kyverno is a very good tool. Kyverno. It prevents, for example, developers to create a privileged pod. You can create policies and say, no, you cannot do that because it's dangerous. So you still allow developers to do whatever they want. You don't restrict them um, formally, but you have these guardrails with Kyverno that um, prevents attack. Um, what can you do next? You have some CI/CD tools that can rate your pod and say it's not secure enough, but I don't really like them. Try to have some good patterns. For example, use give a dedicated service account to each pod and give it a specific IAM role on your cloud infrastructure to give it the least privileges you can give it. Um, you can also call me and I will tell you what to do.
Well, one thing I was thinking about is,
Yeah.
as a developer, try and run through the demos essentially that you've just shown us today. Like go and see if you can open up a reverse shell into one of your pods, see if you can see what you can find. You know, sort of basically do your own pen testing. Obviously, you can hire pen testers, but uh, you may find something digging around that you would not have found through an hour of looking at config files, for example. Or you would
Yes,
you wouldn't have
that's true.
spotted. Yeah.
I think it's a very good idea if you have some time trying to hack your own infrastructure. You will start thinking as an attacker, try to find good resources to trying attacks. You will definitely get some value from that. Oh, yes. And the next step you can do also is to try to detect attack. At some point, you say, okay, I've done everything that I can do. Next step is try to detect if someone gets inside. And you have tools like Falco Security. It's open source. You can deploy it on your clusters, and it will pop alerts each time there is something that's wrong.
Hmm.
And you can export it to a Slack channel, for example, so you get the alerts and you will know if there is someone inside because you saw how many commands I typed.
Hmm.
I had to dig into the file system. I had to create a TCP sockets. Uh, all these all these things are easily detected. So you will
Yeah,
find out at least.
I'm thinking about like sort of picking out unusual patterns of behavior like that from like the masses of data that's going on within a cluster and like things that are happening. Like that's probably a really great use case for machine learning as well, to be able to pick those kind of very specific things out of a mass of data and
Yes,
like very quickly analyze that kind of thing. So
yes, there
I
are.
I, I don't know if there are. I'm sure somebody has already had that thought and spun up a startup over it. But yeah, that's one of the things that is really exciting to me about like how we can get computers to do more of this heavy lifting for us.
And if
Yes,
you, viewer, work for that startup, let us know and
Yeah,
come to a
absolutely. Get
Scaleway
in touch.
session.
Come and talk on sessions about it. Yeah.
yes. I have some. There is some product I like. It's called Sequoia,
Mhm.
SEK, and it's doing exactly that because it's gathering massive amount of data, and the goal is to use machine learning to try to figure out suspicious cases without having this alert fatigue. I think it's called like
Yes.
that
Yeah.
when you get alerts all the time. So
And you
uh,
just end up ignoring them because they're never useful, except sometimes they are.
yeah, there are a bunch of products that say they can do that. I think it's always a good thing. there still needs humans behind, of course, to analyze it. But yes, it's very interesting field. You can find out some if you measure, for example, the volumetry of the logs or even the volumetry of alerts done by Falco. You can know without looking at all the alerts that there is something wrong because there is a high peak in your
Mhm.
volume. So
Yeah,
yes.
that's super cool. Awesome. Well, we are coming up to the top of the hour. In fact, we are at the top of the hour now for this edition of Scaleway Sessions. My brain is so full. Like, I'm so thank you so much for an
Yeah.
incredible walkthrough of some really, really interesting stuff, Thibault. Thank you so much again for coming on. Is there anything that you would like to plug before you go? Are you speaking anywhere exciting? Anything that you'd like to let us and the viewers and listeners of the stream know?
Regarding that subject, no, I don't think not yet. Maybe we will have some announcements in a few months, but not
Yeah.
yet.
For now, make sure to visit their website.
Mhm. Yes.
And thank you very much. Thank you for your questions, and I hope the viewers will like it too. Maybe it was too much
I
black and
certainly
white.
had fun. And
That's
that's
cool.
all I care. No, that's not true. We do want this thing. We do want everything we talk about to be interesting to others as well. That's why we do it. But yes, again, to anybody who's been watching this as it's come out, this was pre-recorded. Don't be offended that we weren't there responding to any questions that were coming out in the chat or anything. Um, yes, I hope everybody is enjoying their summers. And I think we'll leave it there for this week. Want to be, as Dan always says, respectful of everybody's time. So thank you so much for watching, and we will see you next time.